Hello, I'm Bob Duffy, and welcome to this Vodcast series on Intel oneAPI and CERN openlab. In this episode, we're talking with Marcin Swiniarski. He's an AI research student working in collaboration with CERN openlab, and he's developed an inference engine that's analyzing data from the Large Hadron Collider, and it's quite impressive. Marcin, welcome to the show.
Hi, Bob.
Well, I really appreciate you spending time with us and talking with us about your research. But before we get into the research, I'd like to know a little bit about you first. So can you tell our audience, what are you studying and where are you going to university?
Yeah, sure. So I'm Marcin and I'm a master degree student of control engineering and robotics at Gdańsk University of Technology. And I'm actually deeply interested in technical projects, especially in innovations in artificial intelligence, right? And control systems. Yeah, and currently I'm working at Intel Research and Development Center in Gdańsk. And I'm also a board member of Gradient Science Club, where I do some research in computer vision and reinforcement learning.
Wow, fantastic. So let's start talking about what you're doing. So can you give us a high-level explanation on the research that you're doing and what you're doing with CERN?
Yeah, of course. So my project at CERN was focused on developing an inference engine for custom neural networks architectures that could be integrated into the CMS software stack. And based on the oneAPI concepts, such an inference engine would enable deployment of algorithms on different kinds of hardware in line with the latency required in the high-level trigger of the LHC at CERN.
Really interesting. So I'm always interested in knowing why people are doing what they're doing. So I want to know, do you have something that was an inspiration, a driver, or a motivation to do this type of research?
Yeah, of course. So my motivation to get to this project was to learn about experiments happening at CERN, because they are really impressive, and visit the Large Hadron Collider. I wanted to deliver something useful for researchers at CERN. So what I have done, I decided to apply for the openlab summer student program. Yeah, and I have got selected as an internship with CERN and Intel to carry out the project.
What do you hope that it's going to discover, or how does it integrate with CERN and what they're doing?
So the main idea of the data filtering here and the inference engine itself is to catch up only the most interesting particle collisions in the LHC and store them in the data centers. So I would say that such a behavior would speed up searches for new dark sector particles and novel measurements maybe of the Higgs boson.
Wow. Okay, so let's talk a little bit about where oneAPI fits in. Did you use specific libraries for oneAPI? And in the work that you've done so far, have you found any efficiencies or any performance gains?
Yeah, I did. Actually, I used the Intel oneAPI Deep Neural Network library, aka oneDNN. I used it to speed up algorithms running by CERN researchers. I have built the inference engine actually on the top of the library, of the oneDNN library, used at CERN to oneDNN primitives and making the execution efficient on Intel CPUs. Actually, I have got really good performance improvements using this library. And I managed to accelerate the inference time of the HLS4ML models on CPUs.
Were you working with certain data sets doing this?
I was testing a lot of data sets, but I was working mostly with the jet tagging task problem. So I used the dataset prepared by CERN researchers. And I was testing also my inference engine on the classical problems like MNIST. So I was testing also convolutional layers using in my inference engine.
Oh, very good. I think anyone working with AI understands MNIST, right? That's kind of like the hello world for classification. Jet tagging, that sounds exotic, really interesting, and I'm not sure a lot of people will know what that is. Could you give us an idea of what the jet tagging data set is and how it's used?
Yeah, of course. So the jet tagging task is a multi-classification problem, which researchers at CERN are trying to solve using modern machine learning algorithms. So the jet tagging task is based on 16, as far as I remember, high-level input features, and tries to identify 5 jet classes of particles from the LHC. And they are actually quark, a gluon, W boson, and Z boson, and the top quark. So if a machine learning algorithm is passing the task with acceptable accuracy, we can say that it may be useful in the data filtering system of the LHC.
Well, it's amazing. I mean, I think a lot of us understand that there's this large Hadron Collider. These particles are accelerating, colliding into each other, and then all these other exotic particles come out. It's interesting to know that there's a data set for this to classify all the different elements out there, gluons, muons, Higgs bosons, etc. So it's fascinating.
Yeah.
So could you walk us through, in any project that you do, I mean, you're building your own inference engine, you're working with, oneDNN, you're working on Large Hadron Collider. There's a lot of firsts here. So I imagine that you ran into some issues and you had to solve problems along the way. Could you talk to us a little bit about that experience?
Yeah, yes, of course. Actually, I have wrote a report about that. So yeah, there were many challenges in this whole project. So during the development of the inference engine, I had to understand tools and libraries which I wanted to use and there was some actually inconsistency in the tools which I was using, and one of the inconsistency was the memory mapping in the HLS4ML framework which I was using. So the framework which is used in CERN, the HLS4ML framework, didn't care actually about the memory layout of the models. So I had to understand and decide which layout of the models will be the best and properly map it into oneDNN memory in the oneDNN library, right? And another challenge which I also had to face here was equation mapping to oneDNN primitives. So researchers at CERN are developing new modern machine learning algorithms which don't have its, let's say, equivalent in low optimized primitives in oneDNN library. So, for example, one of the machine learning algorithms is graph neural networks. And here I had to understand the mathematics behind the algorithms. So, for example, graph neural networks, and combine oneDNN primitives in such a way that they will do the same operations as the algorithm defined in the publications. So, mapping the algorithm to oneDNN primitives make you sure that it will be efficiently running on Intel hardware. Here also the knowledge gained during my experience at Intel was really useful. And and the last but not least was also a challenge with separating the neural network compilation and execution. So let's say when we have a model generated by the inference engine, we want to compile it once, of course, and process the data through the model many times, so we don't sacrifice model performance by the compilation phase. Because if you would compile it every time we process the data, it would take a lot of time. And this problem I also resolved. The model generated and compiled by the inference engine is stored in the project as a shared object in a memory and available in the Python script. until the process is completed. So I think, let's say it's enough if I explain that way. I don't want to go through the implementation details, but of course there were many challenges which I had to face.
Groundbreaking work is what it sounds like, and I understand other people are already using it. We were talking to Bartek and he's using your reference engine. So I mean, just it's mind-boggling to me that you were mapping the algorithms to the DNN primitives. So very, very good. And it's great. Thank you for doing that work. Others will benefit from it. And it sounds like, from what I understand, this is CPU-based workloads at the moment, but you are using oneAPI, which is really known for heterogeneous computing and working across architectures. So could one assume that even though that you've seen performance improvements on CPU, that the work could also be used on other architectures like GPUs or FPGAs?
Yeah, sure. The inference engine could be applied to any other Intel architectures in line with the oneAPI concepts which you mentioned. And it actually doesn't require any changes in the model.
Yeah, very good, very good. Well, benefit of oneAPI, that's fantastic. So were there any moments in this, you talked about kind of the trials, tribulations, the workarounds that you had to do here, but any kind of moments of fun or glee or things that were just really kind of cool or fun for you in the project?
Yeah, I liked the most actually an exploration of experiments happening at CERN and understanding the basis of physics at CERN. I feel like I was a newbie in physics, and now after this journey, I feel like I understand more from physics, and that's great.
Oh, that's fantastic! Yeah, really, really, really cool. So, speaking of, now you're a bit of a physicist yourself. If you had to explain your project to somebody who's not a physicist or even an engineer, how would you describe it?
So I would say that this project is based on developing a tool using Intel libraries that will accelerate data analysis from physics experiments which are happening at CERN. What's more, no matter what hardware do you have, you can use the project to do the data analysis.
Oh, excellent. Yeah, that's a great summation. It sounds fantastic. Okay, so what's next, Marcin? Where do you go from here? What lies in your future?
Well, I plan to stay with Intel. Not many people know how much Intel does in artificial intelligence and machine learning space. We develop both hardware and software for AI. For example, OpenVINO, Neural Compute Stick, or oneDNN library which I was using. Moreover, last year Habana Labs become part of Intel, and Habana team creates dedicated AI hardware and amazing technologies that will shape the future of the AI. So if you ask me about my future, I hope to continue doing what I'm passionate about, contributing to the team, and have my share in bringing some breakthrough AI tech to the market, I would say.
Well, I hope it's true, because you've already done amazing work already. And like I said, others are already building on top of your work. It's fantastic to see this kind of work being done at your level. So, Marcin, I really appreciate you joining us. Thank you for taking the time.
Yeah, thank you too, Bob. It was pretty impressive.
Very good, very good. Okay, so for the rest of you, if you want to learn more about Intel oneAPI, follow the link in the description below to the Intel Developer Zone. And if you enjoyed this content, like the video, subscribe to the YouTube channel. And on behalf of a fantastic production crew who's putting this together during COVID, during the pandemic, Marcin and I are at our own places doing this. We thank you for taking the time and joining us. But until next time, I'm your host, Bob Duffy, and we'll catch you later.